Scientists from Nanyang Technological University say they have developed a new drug-free approach to killing cancer cells. Anti-cancer therapeutic nanoparticles are coated with amino acids that cancer cells need. Now, this allows them to enter and kill the cells. Lab tests show results are comparable to treatment using conventional drugs. Well, joining us tonight to share more about the treatment method is Assistant Professor Dalton Tay from NTU's School of Materials Science and Engineering and School of Biological Sciences. Good evening, Professor Tay. Thank you for joining us. Can you please explain how your new approach works? How does it differ specifically from existing cancer therapy methods?
Good evening, Dawn and Steve. Thanks for having me on the show. So our lab recently developed a novel cancer nanomedicine. We term this as nanoscopic phenylalanine amino acid mimic, or nano-PPAM in short. What is unique about nano-PPAM is that it exhibits intrinsic anti-cancer properties, and therefore we are able to achieve cancer-killing effects without the use of any toxic chemotherapeutic drugs. Nano-PPAM can be described as a silica nanoparticles that is covered by a coat of phenylalanine. So this is an amino acid you can find abundantly in protein-rich food like milk, egg, and meat. The particles is about 30 nanometer in size, and to put things in perspective, this is about 25 million times smaller than a basketball. So it works by exploiting the amino acid dependency of cancer cells, which is a source of nutrients to fuel their growth. Conventionally, researchers would have thought of limiting the intake of amino acids through dietary restriction to starve the cancer cells. Our approach is a bit different. We have decided that we will overfeed the cancer cells with amino acid, except that these are cancer-killing nanoparticles disguised as amino acid. So once these particles are inside the cells, it will stimulate excessive amount of reactive oxygen species production, causing the cells to destruct through a process known as apoptosis. So just like how the Greeks were able to use Trojan horse to sneak into Troy, we were also able to replete cancer cells with nano-PPAM and destroy it from the inside.
Fascinating to hear how it works. Based on the results from lab tests, how effective is this method then?
With nano-PPAM, we were able to achieve a cancer-killing efficacy of about 80% in human skin, gastric, and breast cancer cells over a treatment period of about 24 hours, which is comparable to conventional chemotherapeutic drugs like cisplatin. Additionally, in breast cancer tumor-bearing mice, we were able to suppress tumor growth by about 60 to 70% against the untreated group. And very importantly is that nano-PPAM only destroys cancer cells and is non-toxic to healthy cells.
Professor Tay, let me just ask you a little bit more about that. You mentioned that it can be used for different types of cancer, for skin cancer. You've seen results for skin cancer. You've seen results for breast cancer. Is it suitable for all patients, though?
Well, the materials that we use is actually a US Food and Drug Administration designated, generally regarded as safe material. So it is not expected to be toxic and should be amenable to patients with other types of cancer. So far, we have shown that it works in skin, gastric, and breast, like what you've mentioned. But more recently, we're also getting very encouraging results in bladder cancer.
And when can we expect the treatment approach to be available?
Well, our research is still in the early stages. Further study would still be required to compare the effectiveness of nano-PPAM against a larger panel of drugs, as well as to identify the types of cancer that will be best suited to be treated by nano-PPAM. Additionally, the long-term safety of nano-PPAM needs to be evaluated before we can proceed to human clinical trials and plus the other regulatory approvals that is required. So realistically speaking, we are looking at a timeline of about 10 years. But conceptually, it's very important at this stage because we show that nanoparticles can be designed to behave like anti-cancer drugs. We are currently looking to translate our findings, and it's very keen to co-develop our platform technology with industry partners and pharma companies, with the possibility to fast-track the bench-to-bedside translation process.
Okay, we wish you all the best with those endeavors. Assistant Professor Dalton Tay from NTU.